All right, in today's lesson on 1.5, we are looking at combinations and compositions. Again, this is a review topic from Algebra 2 days, so hopefully this rings a bell. But let's look at this. We're adding functions. We are adding and subtracting first. So in theory, what's happening is you have one function f, one function g, and we add them. So notice the notation. We can combine it like this, but that just means we add them. If we subtract, it's just exactly what it sounds like. It's subtracting. So what does that look like in practice? Well, we're going to let f of x equal this expression, 2x minus 3, and g of x be x squared minus 1. So the first example, f plus g of 2. All right, so here's what we're going to do. I'm going to take f plus g of 2. So I'm going to first add the two equations. So 2x minus 3 plus x squared minus 1. If I combine my like terms and put it in exponent order, I'll have x squared plus 2x minus 3 minus 1 is negative 4. Now I need to evaluate it where x is 2. So I'm going to have 2 squared plus 2 times 2 minus 4. Well, that's 4 plus 4 minus 4 is 4. So there's that answer. Let's look at number 2. This is f minus g of x. So notice there's no number here, so there will be an x in my answer. So if I'm subtracting the functions, I'll take that 2x minus 3, and I'm going to subtract that g of x function. So always take a moment and put parentheses around it so you can distribute correctly, because it's easy to forget to distribute that negative. So 2x minus 3 minus x squared plus 1 when we distribute that negative. So then I put it in exponent order, negative x squared plus 2x minus 2. So notice my answer on this one has an x because x was in the original question. It did not give me a number here. So number 3 is f minus g of 2. So it's the same thing we just did. It's subtracting the two functions, but then it's taking a 2 and plugging in for x. So all I'm going to do is take what we just did and plug in the 2 for x. Now, the negative is on the outside, so be careful here. 2 times 2 minus 2. All right, so negative 2 squared, 2 squared is 4 times the negative out here is negative 4 plus this 4 minus 2. Well, that gives me a negative 2 for my answer. All right, so adding and subtracting expressions, there you go. Now the next thing we're going to do is multiply. So when we multiply expressions like this, we would use FOIL, or we would use box method, or something like that. So let's look at our notation, f times g of 2. All right, now a couple ways you can do this. Since there is a number here, you can take that 2 and plug it into f. So f of 2 gives me 2 times 2 minus 3, which is 4 minus 3, or 1. And then g of 2 would be 2 squared minus 1. So that's 4 minus 1 is 3. And then multiply my answer. So I'll have 1 times 3 equals 3. So you see what I did there? I found f of 2, and then I found g of 2, and then I multiplied them. That works great if there's a number, but what if there's not a number? If there's not a number, then we have to do just basic FOIL. So I'll have 2x minus 3 times x squared minus 1, and then we'll FOIL it. So first terms, I'll have 2x to the third, outer minus 2x, inner minus 3x squared, and last is plus 3. Now let's put it in exponent order. So 2x to the third minus 3x squared minus 2x plus 3. And that's how I have to leave my answer because it doesn't give me anything to evaluate x for. Now when we combine functions to divide, division is just the one equation divided by the second equation. So don't make it any more complicated. 2x minus 3 divided by x squared minus 1. Now sometimes you'll look at this and there's ways to reduce. You could take a GCF out or potentially factor out and divide out. But in this example, this is all you can do. There's nothing more to it. All right, so I'm dividing. So notice on example 6, I have a value, a 0. So I can plug in the 0 first into my two expressions and then divide my results. So I'm going to do 2 times 0 minus 3. That is negative 3, right? And then I take my g of x, 0 squared minus 1 is negative 1. So when I divide, I'll have negative 3 over negative 1, which gives me a positive 3. All right? Now, that's nice and easy when there's a value, but look at number 7. There's no value. We have to leave x as it is. So when I stack my expressions, because that's what I'm dividing, now I can't do anything to this. There is no simplifying it when things are attached with a minus or a plus. You can't cancel down. You can't cancel across. This is where it stays. All right? If you could take a greatest common factor out, potentially you could reduce, but in this case you can't. So don't be alarmed if you can't always reduce. All right, now let's try combining functions. This is just taking this up one more notch. What if it's t minus 3? So if I take f and I plug in t minus 3 for x, I'm going to put in 2 times t minus 3 minus 3. Okay, I'm just taking this expression and plugging in t minus 3 over g of x, plugging in t minus 3 squared minus 1. So let's clean this up for a moment. The bottom, this one I'm going to have to FOIL this. So I'm going to have to do t minus 3 times t minus 3, which would give me t squared minus 6t plus 9 minus 1. So when I clean it up, I'll have 2t minus 6 minus 3 over t squared minus 6t plus 8. Not quite finished because I can combine these terms, so I would finish by saying 2t minus 9 over t squared minus 6t plus 8. All right, so it looks a little messy, but look, we're just plugging in an expression into the equations. Let's try number 9. This one we're multiplying the functions, but we're plugging in 5t cubed first. Okay, so 2 times 5t cubed minus 3 is going to give me what? 10t cubed minus 3. And then I take the g of x, and it says 5t cubed. I have to square that minus 1. So when you square that, it's going to be 5 squared is 25. T cubed squared is, remember, we multiply when we raise it to a power. So it'll be t to the 6th minus 1. Now this is a hot mess, right? But when we multiply these, now we have two binomials. So we're going to have some high exponents, but don't panic, it's fine. So when I multiply these two together, I'll have 250. When you multiply, remember you just add them. T to the 9th. Last terms, or outer terms, I'm sorry, 10t minus 10t cubed. Inner would be negative 75t to the 6th, and last would be plus 3. Now we just put it in exponent order, so I'll have 250t to the 9th minus 75t to the 6th minus 10t to the 3rd plus 3. All right, let's look at example 10. Same idea, we're just going to be dividing. So we're going to plug in 3t minus 1 into our equation. So if f is 2 times x minus 3, I'm going to put in 3t minus 1. And then down here, it's going to be 3t minus 1 squared minus 1. Now if we clean that up, we're going to have 6t minus 2 minus 3. Now this means I'm going to FOIL it, right? 3t minus 1 times 3t minus 1 minus 1. So when I do all this, let's see what I get here. I'll have 9t squared minus 3t is minus 6t plus 1, and then the minus 1 hangs off the back. So when I reduce this and simplify, I will have 6t minus 5 over 9t squared minus 6t. The ones will go away, and that's it. Now, this is where I leave it. I cannot cancel this 6t and this 6t. They are connected by, in this case, minus signs. You can't reduce like this when they're an expression. So don't be tempted to do that, all right? And you can't reduce here by 3 because, again, these are connected in the expression. You can't take those out. All right, let's move on to the next section here. Next section has to do with compositions. This is different, all right? Compositions are different. Compositions is when you compose one function of another, when you put one into the other. All right, so f of g of x. So what you're going to do is take that first f, or the first letter, is the function that gives you the structure. So I'm going to take that structure of 3 times something x plus 5. And I need to plug in whatever it says to plug in. I'm plugging in g, so it's 5 minus x. Now I'm going to distribute and clean this up. So I'll have 15 minus 3x plus 5. And my answer then will be, when I combine like terms, I'll have 20 minus 3x. And that's my answer. See how I composed it? Now look at B. This says g of f of x. So g is the function or the structure we're going to start with here. So we're going to say 5 minus something. In this case, the something is f, the function of f, or the expression of f. So then I plug it in. Now I go back and clean it up by distributing the negative. So 5 minus 3x minus 5. So when I continue to combine like terms, 5 minus 5 is 0, and I have negative 3x. And I'm done. Now, f of g of 0, all right? F of g of 0. So we're going to do the same thing. Take the f function like we started with, 3 times something plus 5, and we're plugging in g, 5 minus x, clean it up. If you remember, that gave us 20 minus 3x. Now we're at the place where we can plug in the 0. So now I'm going to plug in a 0 here. So 20 minus 3 times 0 leaves me with just 20. And there's my answer. All right, let's look at the next section. Some more examples, just a few more. New expressions here to work with. So given that f of x is 2x squared and g of x is x plus 4, let's do this. So f of g of x, so f is the structure, so 2 times something squared, and I'm going to put g in there, x plus 4. Now, this means I have to FOIL, so this is x plus 4 times x plus 4. If I FOIL this, I will have x squared plus 8x plus 16. I got to distribute my 2, so I'll have 2x squared plus 16x plus 32. B says g of f of x. So I'm going to take the g expression, something plus 4, and I'm going to plug in f. So I'm going to put 2x squared in there. Well, there's nothing really to do here because there's nothing to distribute. That one is understood. So I'll just have 2x squared plus 4, and I'm done. X is left here, so I don't have to plug anything in. Now C says f of g of 0. So it's the f structure plugging g in. Isn't that what we did right over here? So I know that when I plug g into f, I end up with this thing, right? And now it's just asking me to plug in a 0 for x. So 2 times 0 squared plus 16 times 0 plus 32. Well, that's 0 and that's 0, so my answer is just 32. All right, so when we get into class, we're going to start here. I would encourage you to try these on your own, and let's just see how you did when you get to class. All right, thanks for listening.